Okay, so this is a video on the material in section 2.7, which I think is the hardest section so far. Maybe it might be one of the hardest sections in the whole course. And we do it, near the beginning of the course. And it's a precise definition of a limit. So I'm going to give, if you look at my announcement that I put on Canvas, I'm going to give what I think are some of the easier problems. A lot of the problems in this, if you go into my lab, a lot of the problems are about really test your definition of the definitions of a limit. And I think it's hard. And you may just have to look at examples online to answer some of the questions. I do think that the problems are difficult. So it's good if you're a math major, and the problems are kind of long, so it's easy kind of to make a mistake somewhere along the line. Okay, but we do talk about limits. Calculus is all about limits. And so we have this kind of intuitive sense of what a limit is, but this will give us a more formal sense. So first of all, remember, what does it mean for a function to be continuous at a point A? Well, first of all, a function, if the function is f, a function is continuous at a point A. Well, first of all, f of a has to be defined, and the limit as x goes to a from the right and the limit as x goes to a from the left are equal, and f of a has to be equal to that limit. Okay, so here we see, if we look at this kind of drawing right here of this line, it's minus 2x plus 5, and you can see there at 1, well, the function, at 1, the function is equal to 3. And so what the limit says is that, as we get close to x, if we get close to, we get close to 1 on the x-axis from either direction, we get very close to f of x equals 3. So on either side, you can see, so a little bit to the left of 1, maybe the function's about 3.1, and a little bit to the right of 1, the function's 2.9. And so we can get within 0.1 of 3 if we get close enough to 1. Okay, so and so in this case, so if you actually just solve the equation, minus 2x plus 5 equals 3.1, we get x is 0.95. So, and then if x is, and then if we solve the equation here, minus 2x plus 5 equals 2.9, we see that x is 1.05. So if we're in this interval from 0.95 to 1.05, f of x, we see that f of x minus 3 is less than 0.1. Okay, and so we can actually make this epsilon, but we can make the epsilon even smaller, right? You can make it 0.5, and then you have to make the interval even smaller. My f of x looks terrible, doesn't it? See if I can make that a little bit better. Okay, so f of x is minus 2x plus 5, and we know that f of x minus 3 is less than 0.1 if x is in this interval right here. And so that epsilon equal to 0.1, that was arbitrarily chosen. Make it 0.05 or 0.01, and then you'll need even a smaller interval. But the idea is that you can get close to f of you can get close to 3 as you want, just by restricting your interval. So in this case, if we make the interval from 0.95 to 1.05, f of x gets within 0.1 of 3. It never breaks out of that range. Okay, so here's our formal definition. And students, I'm not going to test, you're not going to be tested on the exam or any quiz on this. So, but the homework does kind of ask these questions, and especially because it's online, I think it's even more difficult the way they formulate these questions. So you just have to read them carefully. So I kind of, I'm gonna say, you might find the homework difficult. And I don't know if I've really said this about any of the other units. I'm not trying to discourage you. I just think the homework here is hard. I'm just being honest. Okay, so we're saying that the limit of f of x as x goes to a is L. It means that we can get, when you choose any number epsilon greater than 0, and epsilon is usually considered a really small number, 0.1, 0.01, 0.001. So we can get as close as we want. So f of x gets as close as we want to L if we restrict, if we can, okay, let me say again. So we can get within, f of x minus L is less than epsilon if we get within some delta of A. So for every epsilon, there exists a corresponding delta greater than 0, that f of x minus L is less than epsilon when x minus A is less than delta. So like in our problem here above, we chose epsilon equal to 0.1. And so so the absolute value of f of x minus 3 in this problem here, the function was minus 2x plus 5. F of x minus 3 was less than 0.1, and our delta in this case was 0.05. So you get within 0.05 of 1, and then f of x minus 3 is less than 0.1. So let's there's just a couple other problems here that we'll look at. And you're not going to do this on the test, what I'm doing right now on the test. And then actually I have one other problem. Let's look at a homework problem that kind of might be a kind of problem you might see on the test. Okay, so let's just look at this epsilon delta definition. So we choose epsilon is the independent value, delta is the dependent value. You choose epsilon and then you find your delta. Okay, so in this case, now we have the graph of it's a line 2x plus 3. And so what we're saying is that the limit as x goes to 5, the limit is 13. So yeah, so that's kind of intuitive. We can actually just do direct substitution in this case. You just let x equal 5, and you see that f of 5 is 13. And if you graph it, yeah, you can see that the limit is as x goes to 5 from the right or from the left is equal to 13. So let's just use this kind of strict definition right here. So you choose any, so if you choose any epsilon, what's your delta? Okay, so so we're looking at the limit as x goes to 13. So we're saying that 2x, I'm sorry, we're going we're looking at the limit as a goes to 5. Okay, I'm sorry, as x goes to 5. As x goes to 5, we know that f of x is 13. Okay, so so here's your function. And okay, so if 2x plus 3 minus 13 is less than epsilon, where epsilon is some arbitrary value. Okay, well, let's simplify that. And you get 2x minus 10 is less than epsilon. So just divide both sides by 2, and x minus 5 is less than epsilon over 2. So if you're, okay, so you choose your epsilon, and then if delta is epsilon over 2, we know that 2x plus 3 minus 13 is going to be less than epsilon. So that's actually, I think, a little kind of confusing right here. Okay, so if I can actually draw that, and I think it really helps if you draw this. And let me try that one more time, students. A little hard because my screen's vertical. So here's your graph. And let's say this is x, let's say that's a equal 5. And then you choose your epsilon. And so we know that f of 5 is 13. Okay, and so what it's saying is, so on either side, this would be 2 epsilon. Okay, so either epsilon up and epsilon down. And what it's saying here is if you choose this range here where from here to here is epsilon, then f of x minus 13 will be less than epsilon if a minus 5 is less than epsilon over 2. And students, a good exercise might be just to try something like this. So in this case, we actually chose epsilon is 0.1, and then we found the delta is 0.5. So you actually just might want to choose an epsilon here and then see what the delta is. And do something similar to problem 1. Okay, it gets harder. So students, when the function's linear, it's really very easy. You choose it, and students, if you found, this is what you do if you're a math major. Like what we do right here, this is for math majors. Not for engineers. Okay, so okay, and okay, so it's easy when the function is linear, but what happens if the function's nonlinear, like x squared? Then it really gets kind of tricky. Okay, so here we actually are given an epsilon. So okay, so we know that, okay, let's say okay, we're going to choose our a equal 4. So we're going to show that the limit as x goes to 4 is 16. So we're going to use this, and again, you can just draw the graph. We know that when we draw the graph, we know it's continuous because essentially it's that kind of intuitive definition of continuity. We can draw the graph without lifting our pencil. Okay, but we want a rigorous definition that as x goes to 4, the limit is the limit as x goes to 4 of x squared is equal to 16. So we want to show that we can get as close to 16 as we want. If we make x sufficiently close to 4, x squared minus 16 is going to be less than epsilon. In this case, let's just choose our epsilon equal to 0.001. So we can get really close. If you go either to the little bit to the left of 4 or a little bit to the right of 4, f of x minus 16 will be less than 0.001. Okay, here. So okay, so you choose your epsilon to equal 0.0. Remember, the epsilon is the independent. Now, what would our delta be? How close do we have to be to 4 to make f of x minus x squared less than 0.001? So we're going to just solve this. So let's just assume. So usually this is. So let's look at that inequality right there that I circled, and let's see. Okay, so it's an absolute value. So by definition, if x squared, the absolute value of x squared minus 16 is less than 0.001, by the definition of absolute value, that means negative 0.001 is less than x squared minus 16, less than 0.001. So solve for x squared, add 16 to both sides, and now you get x squared is has to be within the range. So basically, if we're going to assume that x squared minus 16 is less than 0.001. If that's true, you can then eventually conclude that x must be greater than the square root of 15.999 and less than the square root of 16.001. So if x squared minus 16 is less than 0.001, we know that x has to solve this inequality down here. It's got to be between the square root of 15.999 and 16.001. Okay, now let's just subtract 4 from each side. And well, it turns out you're going to get, what you're going to do is going to get x minus 4 is less than 16.001 minus 4. So if the absolute value, so we're just going to take this, okay, so if the absolute value of x minus 4 is less than the square root of negative, I'm sorry, if this absolute value of x minus 4 is less than the square root of 16.001 minus 4, then we know that if this is true, so this is our delta. It's kind of, see, it's hard. I'm doing, so when the function's not linear, it's hard. So when that's true, when the absolute value of x minus 4 is less than square root of 16.001 minus 4, we can claim that x squared minus 16 is less than 0.001, right? And so the idea is that you can keep choosing this. You can make the epsilon even smaller, and then then the delta is going to have to be smaller. But the idea is we can get from the left or the right, we can get as close to f of x as close to 16 as we want. Let me just say one more thing, because I do think this is kind of a hard lecture. Okay, so let's go back to this first function here. Minus 2x plus 5 equals 3.1. Okay, let's say this function had let's say actually had a discontinuity. Let's say, okay, so f of x, let's say f of x is 2x plus 5 everywhere except at 1. And let's say at 1, let's just make this, let's just say it's 4. So, okay, so let's just say, assuming x naught is equal to 1, let's just assume, what can I write in this? F of, it's not allowing me to write. Oh, sorry, students. Sometimes I don't know why it does that. So let's just assume f of 1 equals 4, okay? And everywhere except for 1, it's the line minus 2x plus 5. Now, this epsilon delta thing is not going to work. It doesn't matter how close, right? So if I get really close to x equal 1, f of x minus f of 1 is going to be big, right? Right. So like here, just to the left of x equal 1, f of x is going to be about, let's say it's 3.1. So if we go 0.1 to the left, I know that f of x is 3.1. Well, 4 minus 3.1 is 0.9. So there's no way when I come from the left, I'm not going to get near, f of x is not going to be near 4. And when I go from x to the right, f of x is not going to be near 4. So there's no, I don't care how close you get to x equal 1, f of x minus f of, assuming f of 1 is 4, because there it's not continuous, right? So if you look at f of x minus f of 1, there's going to be a gap. Okay, so the difference between f of x and f of 1 is not going to be small. Okay, so so if f is not continuous, this epsilon, you can't do that. This epsilon delta process doesn't work. So let's just look at a problem which I think there's a couple types of problems in some of the, I think some of the homework problems are difficult, but here's one I kind of like. And this was, I think, I don't remember which problem this is. Well, here it says problem 4. Okay, so from section 2.7. Okay, and I kind of like this problem here. And so you actually, and I like it because we look at the graph. Okay, so here we have this this function here, and it says determine the largest value of delta that satisfies the statement. So how far away can we get from, so in this case, this is actually, we know that if you just look at this, f of 2, that hole there is actually 2. So this is actually what's called a removable discontinuity. If we just find f of 2 equal to, the function would be continuous. So it's saying here, okay, so how far away can we get from 2 down here on the x-axis and make f of x minus 2 less than 1? So let's go up here. That's 3. So there's y equal to 3. And then let's go down here, down to 1. Well, it's not allowing me to draw. Well, so we wouldn't do that. Okay, and so so we can get, so f of x minus 2 is less than 1. Okay, so where is this 3 here? So f of 1 is 3, right? F of 1 is 3. And what about 1? And then f of 3 is 1. Okay, so in this case, if we get to, so if we go, so for 1 away from 2, so it's this interval right here, from 1 to 3. So if we choose any x in that interval, f of x minus 2 will be less than 1. So in this case, our delta is 1. This isn't very helpful. Okay, so, well, it turns out the delta is 1. Sorry about all this jumping. I'm supposed to be able to write on this. It's not allowing me to do it. Okay. Okay, so your delta is 1. Okay, so meaning you go 1 to the left from 2 or 1 to the right of 2, f of x minus, if x minus 2 is less than 1, then f of x minus 2 is also less than 1. So let's say you choose f of x equal 1.5, you'll know that f of x, like right here, that's in the interval from 1 to 2. You know that, like, in this case, f of 1.5 minus 2 will be less than 1. And so now they actually have this second problem. Okay, so you want to know how far can you go from the left or the right to get within 1/2 of 2. So again, you just have to look at the graph here. And so I like these ones where you look at the graph. So it's here and it's here. And it turns out you're going to go 1/2 away. So you might see a problem like that on the quiz, or not the quiz, the exam. Okay, so